Okay, now we can go to our live demo. So maybe now you can see my SpaceClaim.
Yes, sir.
Okay, so this is the SpaceClaim GUI. I will just give you a short overview of the GUI. So it has some design tools here. So some basic design tools like sketch functions, and then you have these extrusion functions. I won't go into a lot of detail about that. I want to present some real life examples first. So these are some sketch functions. You can do some full extrusion functions really easily. So you can extrude and you can create another extrusion here. With the same pull function, you can either extrude or even cut with the same function. And then you can do some loft features, some split bodies. So if you're aware of these terms, it's good enough. I will cover it in the future course, but right now I will just to give you a short overview of these functions here. But what I want to do is I want to show you some real life examples. So let's say okay, so this is a generic fan geometry with a casing around it and the nose cone. So this jet engine fan is something that you might have to work with in the industry. And what here I want to show you is here, as you can see, some of these objects are really transparent. So what this implies is there are some gaps in the geometry. So if you're working in the industry, you would know that these different parts have come from different design teams. So they all have their own format in which they export their parts to you. So maybe someone has exported maybe a wrong tolerance part, or maybe a part that is not watertight. So that is why we see some artifacts of it being a surface here. However, this fan is a solid, but what we need for an FEA or a CFD analysis is geometry to be watertight. So SpaceClaim has this really automated tools to repair your geometry. So there is this repair tab where you can navigate to. And because you think that there are gaps, because the part is not a solid, you can check for gaps. Here it shows me that there are no gaps found, but then maybe there are some intersecting faces, and now it finds some missing faces. So there are some missing faces on the nose cone here. There are some missing faces on this casing rear end here. So what you can do is simply tell SpaceClaim to repair it, and now it's a solid domain. So this is something that is really useful, because you could see in 1 or 2 steps, you could go from a really dirty geometry that is not so airtight to a really clean geometry, and it creates the surfaces that are missing by itself. One more thing, that if you're working on a CFD simulation, you might have to clean this screw or this feature up. You might not need it because it might cause some added mesh errors or added mesh expense, because you would need to put a lot of fine mesh in this region to capture it. So what you would rather do is just remove this feature. So for this also, there is a really easy tool which you could use. You could just fill this up. So you ask SpaceClaim to fill it up. You go to fill, design, fill, and then just click on the surfaces that you want to remove. Okay, now as you see, it's filled out, and SpaceClaim is smart enough to fill it out as, let's say, a rounded feature rather than just a flat feature on that screw feature. So this is something that makes SpaceClaim a bit more user-friendly, let's say. So now we have this final part which you could then send to your simulation software. Now another example I wanted to look into was a 3D printing example. So now we have this Stanford bunny. This is a very generic and open source geometry that is available from the internet. And what we see here, there are some open gaps on the legs of this bunny. And what we want to do is we want to fix these gaps, because if we just simply send this to the printer, it will not print. So what we do is go to the repair tab. We go to this facets tab, and we just say auto fix. First select the body, and then okay. So now as we see, it has been auto fixed. So there have been some triangles that have closed these gaps on the foot of the bunny here, as you can see. So this is how you can simply auto fix your geometry. So the second thing you would like to do with such a solid body is to remove parts from your bunny. So you want to have it as a shell before you print it out. So you don't want to be wasting a lot of material by printing out a solid body. So it has this, ANSYS has this shell feature where you can simply navigate to, and let's say we put in the thickness of the shell here. And additionally, it also has this feature of creating the infill in the domain. So what this means is when you want to print a body, you don't just print the shell, but you put some infill into the body as well to, let's say, make the body more rigid and make the print more robust so that it does not fail during the print. So we say 10% of infill and a length of around 3 millimeters and a thickness of 0.5 millimeter. Should be okay. So now you can already see how the infill will look like inside the bunny. It already shows you a nice preview. And now, because I want to show you from inside, I will just remove the feet of the bunny from my selection so that we can see inside the bunny. This does not select the entire thing. I will have to switch my view to through selection through the whole bunny. And now we see it selected the whole thing. Okay, so now as we can see, it has shelled the body with 2 millimeters thickness, as well as created these, it's not very clearly visible, but it has created these facets inside the bunny, or not the facets, but the infill inside the bunny with what we defined in the infill feature here. So I hope you can see it because the color of ANSYS is not so good, but I hope it's visible. Okay. So the last example I wanted to highlight was more of an electronics package example that we will also hopefully try to simulate in Discovery Live. Okay, so this is a generic electronics package box. For this, I have to thank my previous colleagues at my previous company, SimScale. And this is an electronics box with a casing around it. So there are some chips inside with some electronic components and also a heatsink. And now what I want to show you here is if you want to simulate such a geometry, such a generic geometry that most of the electronic packages look like, if you want to simulate it, you usually do a conjugate heat transfer analysis. And for that, you need, right now you have the solid domain, but you also need a fluid domain. So creating a fluid domain can be really tricky if you're working with your normal CAD tools. But in this case, it's a really two-step process where how you can create your fluid domain. So if you simply go to prepare and extract your volume, you can just do these two, you can select these two bounding faces, and you can select a seed face, which tells the software which face is inside your fluid domain, and simply click OK. So now you see it has created the fluid domain around all your electronics components. So I'll do a quick cut of this fluid domain. So hide all. Okay, so as you see, the fluid domain has indeed been created around our electronic components. So this just is a validation step to verify that the fluid domain is not skipping off any of our electronic components and just creating the domain there. Okay, so this was just a quick overview of how you can create a fluid solid domain for a conjugate heat transfer simulation. This is really useful in, as I said, in the electronics as well as the aerospace domain. Okay. Okay, so now I think we have enough time. We can maybe look into a quick simulation of this fluid domain in SpaceClaim or in Discovery Live. So I'll close this. Okay, so the fluid solid domain that we had created, we can load it into, I hope you can see my Discovery Live now. Yeah.
Yes, we can see your screen.
Yeah, perfect. So what we created in our previous step, we'll try to load it into our Discovery Live. But before that, I just wanted to highlight again, like you can see the GUI of Discovery Live. It looks really similar to SpaceClaim. So as I said, it's a simulation on CAD tool, which helps you to directly define your simulation steps on your CAD. So new, we can say file, open. This is the electronics package that we defined in our previous SpaceClaim step. So here we have the fluid domain. Yeah. So what we simply can do is create your solution. I want to study a fluid. So you click on the fluid behavior and you select your fluid domain that was created. Sorry, I think it is deleting my domain. So I will do it again. Okay, I think it deleted my domain somehow, so I will just create it in quick one step. Okay, now we have it again. Now we can create the solution. Okay, I think it's right now acting strange by deleting my domain. So I think we can just skip this part and maybe move on to our Q&A session. Maybe in the meantime, I can figure this out.
Yeah, sure, sir. We can do that.
Yeah.
And participant, if you have any questions, as sir insisted, you can just drop your questions in the chat box so that I can get your queries clarified. If there are no more questions, I request you to type a no in the chat box.
So Roshan, will you be sorting through the questions or should I look into the questions from the chat?
Yeah, I'll be reading the questions for you,
Okay.
sir.
Okay, perfect.
Yeah. The first question of the day, sir. Can you tell me more about digital twin?
So digital twin is basically what you are producing. So if you're in the development phase of any product, you have a parallel digital 3D model. It does not have to be a 3D model. It can also be a 1D model where you just have some parameters that are in the virtual world. So as you make changes to your product in the real world, you make the same changes to the product in the virtual world, and this tells you how this change would react to your product. So how your product would react to this change. So this is how the digital product technology works. So it can be a 3D model or a 1D model that basically summarizes how your product would adapt to a change that you want to make to your product.
Yeah, okay, sir. Thank you for that explanation. The next question, how to smoothening the part after getting the topology optimized?
So if I get that question correctly, if you want to smoothen, like you want to improve the part surface quality, there are some repair tools in SpaceClaim, such as you want to remove some duplicate surfaces, you want to improve the STL format of your file, then there are these tools in SpaceClaim that you can use. So if I get the correct question right, then there should be the answer.
Yeah, okay, so. And the continuation for the above question, after optimization, part is having organic structure. So how to repair and smoothening the part?
Okay, so yes, so for organic structure, I think you mean a generative design. If you're working with generative design, something like this. I don't think you can see my screen.
Yeah, yes, your screen is visible.
I think it's the wrong one, or you can see the PPT now, yeah?
Yes, sir.
Okay. So yeah, so something like a generative design. So as I mentioned, so STL repair is an option. If you want to do this, there are some options for a facet generation, STL repair in SpaceClaim that you can do. So you can go from this dirty STL file to a more smooth STL file like this in SpaceClaim as well. So this can be done, yeah.
Yeah, okay, so thank you for that. And participant, before moving on to the next question, I'm going to launch a poll. Please make sure you fill in the poll so that it will be useful for our improvement for upcoming sessions. And the next question of the day. Yeah, so can we import geometry in SpaceClaim from other design softwares?
Yes, you can definitely import geometry in SpaceClaim from most of the design software, from CATIA, SolidWorks, all the commercial ones, and also from different open source ones you can do it. So yeah, definitely you can import in different file formats directly as a solid part format, or even as a step file format, or IGES file, or a SPI file. This can be exported from your design software and then imported into SpaceClaim. So this can be definitely done, yes.
Yeah, okay, so we have a question from one of our participants. Can you show us some other cases in Discovery Live in short?
Yes, definitely. I was really hoping to show you this one, because this one I prepared, but something is going wrong right now.
Your presentation is only visible, so your SpaceClaim is not visible.
Yeah.
And participants, if you have any more questions, please type it in the chat box so that we can get your queries clarified. And if you have no more questions, you can just type in a no so that we can wind up with a session 2.
What I can quickly do is just show you an example simulation rather than, so this is a SpaceClaim simulation for external aerodynamics of a truck. So as you can see here, you have this truck geometry, and you have these, you have this bounding box around it, and you have the inlet flow here, what you've defined, and you have your outlet, pressure outlet here. So this is all you need to define. So as you can see here, this is the entire simulation definition. So there is nothing else that you have to do. So what you have to do is simply define an initial temperature that is already usually automatically done. If you want to change it, you can change it from here. You can change your gravity here, not change, but you can define it here. You can define your flow velocity. So you can define it. This is how this flow velocity inlet is defined. And you can define your pressure outlet. And then there are some slip symmetry on the sides and on the top, so that the flow is not interacting with the surroundings. So this was just a brief overview of how simple the definition is. And if you want to, let's say, change this geometry live, you can do this also. So if you simply want to extend the length of this truck, you select the feature and we just move it. So automatically it will be updated in real time. So the simulation is already updated. What you can also do is you can, let's say, select everything, and I select through. And now if you extend it, so if you want to change the geometry for this, you can pull it inside. Let's say pull, and if this is how your geometry might look like, you can also do this, and the simulation is updated in real time. You can also look into some other streamline features. You can look into the real-time licks. So this is also being updated real time. So you can see how the flow is being developed in each 2D cross section. And this can be moved around as well if you want. So this you can move it into dimensions if you want to look into some other 2D cross section. So this you can move here. And you can do a lot of other stuff as well. You can maybe rotate your trailer head by 15 degrees to see how that would react. Let's say I close this. If you want to make this more, let's say, if this is a bit more rounded. So as you see, this is now more sharp, and then you can update your simulation based on this design change automatically. So this is just something that, yeah, simulation on CAD means. So if you take the course, this is something that will be definitely covered on in Discovery Live. So you'll definitely do a lot of test cases with preparing geometry and simulating them in Discovery Live. So there are a lot of other features as well. So you can add some thermal boundary conditions. This doesn't make sense for a truck, but if you're doing an electronics package or a data center cooling simulation, you can add thermal features as well to your simulation. And this is something you will be definitely working on if we do the course together. Okay, so any other questions?
Yep. Can you tell me more about the application in additive manufacturing and rapid prototyping?
Application of SpaceClaim, you mean? Or
Yes, sir.
okay, so application of SpaceClaim, the main application is this STL repair and infill generation. So if you're working in additive manufacturing, you definitely have to create an infill and shell your body out to not waste material in additive manufacturing, because material costs are one of the highest costs in additive manufacturing, as you might know. So you have to create this infill, as I showed you in the bunny example. So this is something that can be done with ANSYS. However, in ANSYS SpaceClaim, you cannot really, if you're working in metal additive manufacturing, ANSYS SpaceClaim is not the tool to generate these support structures that you would need for additive manufacturing. This is done in external tools. Maybe ANSYS would introduce it at some point, but in SpaceClaim today, there is no support generation feature that can be used for additive manufacturing. But definitely for STL repair and facet generation and so on, it is definitely a very powerful tool. Okay.
Yeah, okay, thank you for that. Does the Discovery Live require high graphic card specs?
Yes, so Discovery Live works on a GPU. So my current system has a 4 GB GPU with, let's say, mid-range gaming specifications. So a GPU is something that is very recommended if you want to do some Discovery Live simulations.
Yeah, that sounds good.
Mm-hmm.
Can we also use ANSYS for two-phase fluid volume interaction effectively?
Two-phase fluid volume, you can definitely use ANSYS, but not SpaceClaim. Oh, sorry, but not Discovery Live. Discovery Live is not meant to do two-phase simulations. It's more of a tool for designers than researchers or even like a CFD analysts. So it's more of a intuitive and design tool. So you cannot really do two-phase flow in ANSYS Discovery. However, you can of course do it in ANSYS with Fluent or CFX.